Hey guys, welcome back to another lesson. This is our final one with quadratics, which is so hard to believe. We've been on this pathway with quadratics for quite some time now. We're going to talk about quadratic inequalities. I have a little picture up there I drew of kind of what it looks like. Okay, this doesn't equate to this, just by the way. So let's go ahead and just jump into it. Here's my first example that we're going to try out. We have y has to be greater than this quadratic. Now, what I would suggest first, because we're going to solve this by graphing, by the way. I shouldn't write that down, sorry. Solve by graphing. Okay, that does help if I have a little bit of instruction, huh? What I would do first is come up with a way to graph this by its vertex and y-intercept. Okay, so step one, find the vertex. And then step two, find a y-intercept. That way I have some baseline as to how to graph this. Now, finding the vertex. We have a couple methods, okay? One method was that formula that we discussed in a previous lesson video, which was negative b over 2a, and then we plug that back into the function, or the equation, I should say, which this is a function anyway, to come up with the y value, right? And that was one way. The other way was what we just did previously, which was completing the square. Remember that? Either method would work for this guy. The method that I chose was complete the square because I thought that'd be just as easy. But I don't know. Vote now. I should have a voting poll that pops up right after the video, huh? Or during the video. That'd be really cool. I don't know. Let's complete the square. Why not? Okay. So, x squared minus 3x plus 2. Notice, I'm not going to worry about the inequality sign or y at all. I'm just going to focus on this guy right now. That's it. If you want to put equals y, you could. But like I said, the inequality symbol will come back to us later. Okay? So I'm going to complete the square. And this is my choice. Okay? You could use this and get the same response. So I'm going to go ahead, group the variables together, keep the constant outside of here. I have to come up with a number that'll make this guy a perfect square trinomial. If you remember from a previous lesson, what I'm going to do is take half the b value and square it. So half the b value is 1.5. If I square it, I get 2.25. And then because I'm adding that 2.25, I'm going to subtract it to the outside, which keeps the equation in balance. Okay? I am skipping a lot of explanation with this because we did videos on complete the square, and I'm not going to rehash that whole entire thing out. Okay, factoring this guy, I get x minus, and that'd be what, 1.5 squared? Okay, plus, well, not plus negative, we'll just say minus a quarter when I add those guys up. My vertex is going to be at 1.5 and what, negative 0.25. Okay, that's where my vertex is going to be located. Let me go ahead and this is a hand-drawn graph. No critiques, guys, okay? Be gentle with me. 1.5, which would be roughly here, and then negative 0.25 we'll say is roughly there. There's my vertex point. What's my y-intercept? Go back to the original. If I plug 0 in, it's going to be 2, right? So here's my y-intercept. Now, before I'm done graphing this, or before I actually start graphing it, sorry, look at the inequality sign. Remember back when we talked about inequalities, which is a long time ago, that because there's no equal to sign, I'll have a dotted line. I don't want y values that are equal to this parabola. So I'm going to have a dotted line. It's going to look like this. Okay. Let me just put that down. Dotted. Dotted line. Okay. Now, could I graph more points to be accurate? Absolutely. Could I come up with the solutions and know where the x-intercepts are? Yes. I'm just doing a basic rough sketch graph as to where approximately are all the solutions for this guy. Because with an inequality, do we have one solution No, we have many solutions we're looking for that makes this guy true. Okay? Now, how do I figure out where to shade this guy? What do you think? Well, I have an idea. Why don't we test a point? Right? Remember how we did that a long time ago? I'm going to test out a point somewhere and see if it works. Now, I don't have space. I'm out of space. I'm going to erase this part right here. Okay? Let's test a point. Okay. And see if it's going to make this inequality true. Well, how about 0, 0? That's a lovely point, isn't it? It's a lot easier to work with when there's zeros involved. I'm going to plug this into the inequality. 0 is greater than, let's see, it'd be 0 squared minus 3 times 0 plus 2. Simplify, we get 0 is greater than 2. Bum, bum, bum. No, it's not. Okay, this doesn't work. So does that mean my inequality is going to be shaded outside of this guy? No. Therefore, I could say it's going to be shaded inside this guy. Okay. Now, should we check just to see if it really is? As a good mathematician, we probably should, just to be sure that this is going to work. Let's pick another point. Let's test point 1, 2 out. Okay, 1, 2 would be in that shaded region. Plugging these values into the inequality, 2 is greater than 1 squared minus 3 times 1 plus 2. Okay. Let's see, 1 minus 3 is negative 2. Negative 2 plus 2 is 0. It works. 0 is greater than 2. So I was good. We should be shading there. Okay? And that's it, guys. All of these solutions in here, but not the actual parabola itself, will make this guy true. Those are all my answers. Now, in previous lessons, we talked about what? 2 real solutions, 1 real solution, or 2 imaginary, or I should say 2 complex solutions. Now we're talking about almost an infinity of solutions, but their location depends on where it is on the graph. Okay? What do you think? Good? Not too bad of a process. Once again, could I be more accurate? Absolutely. I could plot more points to make sure that this is going to represent it, this quadratic true. I could use symmetry. So look, if this was at, 0, 2, okay, to get to the middle, it's 1.5 as a distance. I go 1.5 over here. This will be 3, 2. So I can use that symmetry to plot more points to make sure that's going to be accurate, okay? Which you should do, by the way. But just for time's sake and just for this lesson, I'm just trying to get the basic concept down for you, okay? All right, what do you think? Try another one? Yeah, let's try another one. Let's do another one. Let's try this one. Get rid of this. There we go. Okay. Once again, we're going to solve this by graphing. We're going to try to come up with solutions that make this guy true. And there's always more than one solution when it comes to inequality. Or is there always more than one solution? Are there inequality problems out there that are different than that? There are. But I'm not going to say anything right now, okay? Different topic, different lesson, but we get to come up with some. Now, looking at this, I'm going to do something a little different. Instead of completing the square to come up with a vertex, I'm going to use that negative b over 2a, okay? Variety is always a good thing when it comes to mathematics. That's what I'm going to do for this problem. So I'm going to use this guy right here. And in the homework, we talked about where this came from. We derived where it came from, which was really cool. And I think I talked about it in the lesson video. But I might have to record one, to be honest with you, in the future. But we'll see. My b value here would be 4. So it'll be a negative 4. 2 times my a value, which is negative 1 for that guy. Multiply those together, I get negative 4 over negative 2, which just gives me a positive 2. Now, remember, this is the x-coordinate of the vertex. Okay? I want the y-coordinate too. Can't just have one and not the other. Is that a song? Can't have one. I don't know. Plug 2 back into here and see what the y value is going to be. Okay? So let's do that. Negative of 2 squared plus 4 times 2 plus 2. Okay? Be careful. We're applying the negative after this guy, order of operations. Very important with that. Okay? We have a negative 4 plus 8 plus 2. Add those together, I get positive 4 plus 2 gives me a 6. Now this would be the y-coordinate of the vertex. So altogether, it would be 2, 6. Now, I can't talk. What's the y-intercept going to be? Go back to the original. It would be 2, right? It's always going to be the constant, the c term of your quadratic. So it would be 0, 2, which I think the last one was. Didn't mean it for it to be that way, to be honest with you. Okay. One more thing. Solid or dotted? Well, there's no equal to sign. Therefore, it's going to be a dotted parabola. None of the solutions on that dotted line will make this guy true. Okay. Now the fun part. Okay. Let's see, 2, 6, 2, 1, 2, 3, 4, 5, 6. Oh, just enough. Y-intercept's at 0, 2. Now, based off the y-intercept, you can see that this is going to be opening downward, but look at the a value. The a value is negative, which is also a key part, okay? It's going to be dotted. Now, I could add another point for accuracy. We could use some symmetry. To go from here to the middle value was a distance of 2. So if I go a distance of 2 again, I could see there's going to be a point over here, just by symmetry, okay? And that can help us graph this a little bit more accurately. Dotted line. Dotted line. Let me get rid of the middle part. Okay. Big question of the day. Where do I shade? Well, I have to test some points out to be sure. Some people might say, well, wait a minute, Mr. McCullough, I want y values that are less than this parabola. Therefore, shouldn't I be shading in between here? If I shade on the outside, I'm getting all these larger y values, like 1,000,000, 10,000, so forth. And that's not going to make this guy true. You'd be absolutely correct. And there's no problem in logically thinking of that way. The test points are there to confirm what you're saying. Okay? And for this purpose of this video, I am going to do some test points out. Okay? I'm going to erase this stuff because I'm out of space. Goodbye to this. Okay, let's test a point out and see if this is actually going to work. Let's do, I think 0, 0 is a great point to try out. And by testing that point out, we're going to see if it's actually inside the parabola, okay? We get 0 is less than negative 0 squared plus 4 times 0 plus 2. Simplifying it, I get 0 is less than 2. That's correct. Therefore, I can say that everything inside of here are solutions to this quadratic. Should we still test a point to make sure? It might not be a bad idea. Let's try a point way out here. So let's try, I don't know, let's test. What do you think? 7, 0? That's on the outside of this guy. Let's see if it works. We have 0 less than negative 7 squared plus 4 times 7 plus 2. We get negative 49 plus 28 would be negative 21 plus 2, so negative 19. Is 0 less than negative 19? No, it's not. Okay, so we're good. This is going to work out for us. Awesome. Okay. Any questions on that? Just like in a classroom, I have to always ask that. It's part of my dialogue. Any questions? Are you doing okay? How's it going for you today? All right, we're up to 15 minutes. I want to do one more example, and then I'll have to probably do a part 2 video. Okay, just kind of works out that way. All right, next example. And I want to keep this, so let's just come up with a new whiteboard. Okay, hey, as you can see, they have a test Friday. All right, next example. This one's going to be a little bit different. What do you think? What's different about this guy as compared to that guy? Do you see it? This has a y, this doesn't. I'm trying to find x values that are less than 0. That's my goal. Over here, I was trying to find y values that were less than these guys. Okay? Am I going to graph everything when it comes to this guy? No. I'm only going to graph technically the x-axis just to see where it's actually heading. That's it. See the big difference there? Now, if I want to solve this, first I got to figure out a range of values, right? Just like over here, my range of values was either what, inside or outside the parabola. Over here, I'm talking about an x value, or the x-axis. In other words, where on the x-axis am I partitioning? All right, for this to work. Here's what I recommend. Figure out what x values make this guy a 0. Now, I know this is less than 0, but ignore that for right now. Find x values that make it 0. And then we're going to test points inside and outside that range to see what works. Okay? My first step, solve for x by any means. Here's the cool part. You have a lot of ways of solving for this. You have factoring, quadratic formula, completing the square. It's up to you as to how you want to solve this guy. Now, see how the numbers are not that crazy? 4 and 3, negative 4 and 3. Those are pretty nice, decent numbers. And the first thing that popped in my mind is probably factoring. Factoring might be a better way of doing this instead of quadratic formula and so forth, which we'll talk about in the next lesson, part 2. We'll do a problem where quadratic formula is probably the only good method for doing this. I could graph this, by the way, and solve by graphing with an XY table. I'll put that down. XY table might not be the best thing because it's going to take a long time. I'm going to choose factoring, okay? And once again, this is temporarily equaling to 0. I know it doesn't work out here, but it's just temporary for right now. What are factors of 3 that give me negative 4? Go ahead, tell me. Come on, can't hear you. Yes, negative 1 and negative 3. Good job. Adding them up gives me negative 4. Multiplying gives me a positive 3. I have x minus 1, and then x minus 3 equals 0. Okay? Perfect. Now, solve for each one. Do you remember what this is called? What we do next? It's called the zero product property. All right? From a previous lesson. That means either this binomial becomes 0, which gives everything 0 when I multiply it, or this guy is a 0. X minus 1 is 0, x minus 3 equals 0. Solve for each one individually. The first one gives me a 1, and the next one gives me a 3. Both of these numbers are my x-intercepts, remember that, and make this guy a 0. They're not really my solutions, though, because I don't want this to be 0. Okay? When I'm graphing this, remember closed and open dots? We haven't done that in a long time. I'm going to have open dots here at 1 and at 3 because that's indicating graphically that these guys are not solutions to this because it makes it 0. See why I specified that? Now, are my solutions going to be in between here or on the outsides? Okay, that's the next part that we have to figure out. And we're going to do that by testing points. Okay? So let's go ahead and test some points out. Let's test one point that's in the middle here, and that's going to be what, 2, 0? Okay, we have a 0. Yay! But here's the deal. If I'm testing a point out to see if this works, do I need a y coordinate? No, not really. So to be honest with you, yeah, y is always going to be 0. But just to clarify, I know that. I think you guys know that. All right. So I'll tell you what. Instead of doing that, we'll just plug in x equals 2. Okay? That way there's no confusion. 2 squared minus 4 times 2 plus 3, is that less than 0? Let's see. 4 minus 8 plus 3. When we simplify a little bit, 4 minus 8 is negative 4 plus 3 is negative 1. And that is a true statement. Negative 1 is less than 0. Therefore, my solutions are right here. So I can shade or make this line a little more prominent so you can see that. So this is all the solutions, which means 1.1, 1.2, 1.0000009, 2.1333333 infinitely, just going on forever. They will make this statement true, what's in here. So there is kind of like an infinite number of solutions in here. Now we probably should test a point on the outside left and right, which I'll let you do that on your own time. But you'll see that they're not going to make the inequality true for that guy. Okay? 3 examples. One where there's no y and how that's interpreted. Now, could you still graph the rest of the quadratic? Yeah, I mean, it's going to look like this. Okay? But, okay, I want to be very clear on this. I don't need to draw the rest of the parabola because I'm not looking for y values that make this guy true, just x's. So I don't need this guy. Okay? That's why I'm only drawing just this line part there. Okay? All right, I do have some more examples, but I'm not going to make this video any longer than it needs to. It's already 20-some minutes. We're going to stop there, and I'll do the rest of part 2. So hope you guys are doing well, and until next time, guys, I will see you all in the next lesson video. Take care.